累死了。
怎么？你知道他们讲你英文很好，
英文不好，
假的，
不是，其实讲我英文好，你听错，不是我，
不是你，
是我，
是你，也不会讲英文。
是妹。诶，那天你父母来，然后现在
那个，
我来看你啊，嗯，不错诶。
对呀、
主要是这个课会上会
这个车很可能吗？会长，
来劲嘛，
希望下个拜三会解决。
全部全部人很 depressed 懂吗？
这么觉得？
啊，因为今天是我们 AI assignment deadline，
哦
然后那个题目很难，你知道吗？我也
，OK
是，我就算做好了哈，我今天
嗯
修改哦，也是修改到半夜2点。
OK，明白。
然后还有那个
啊，
probability，哦，谢谢啊。
你们连上4个课，哎，
我昨天我
4小时。
昨天上8个钟，做工一样哦，上班一样哦。
爽
不是累才好，可是
啊！
你是难的啊，
哦，
崩溃全部人我来看，全部很焦虑，要 midterm 了哦，又有东西这样多要读哦，读不完哦，怕死了，全部我也是哦，能教完哦，
拜三应该可以讲到这个。
有地方啦，
啊，
可以帮我们能帮我们缩小范围，
下个礼拜，
下礼拜啊，
下个礼拜
你觉得大概要几天可以读完？
几天可以读完？
如果分析几天
的话，一整天应该就可以了吧？但是你平时一定要做练习啊，
有啦，
有做的话，我觉得你花一整天就可以了。
讲到这样简单啊，
应该，
我不
不然这样，最多顶多吧，顶多分2天，因为是 curve 的一部分跟 series 一部分，顶多就2天。
科的一部分什么
是不是所有那种拖拉、graph
啊？
啊，
是啊，
那些
全部
全部东西
弯道曲其实是科分
啊，
啊。
那种整个一部分，然后
那
series 一部分
我问了，会不会就是因为你出 quiz 完了嘛？会不会就可能比较注重在 series 呢？maybe
都有，
都有啦，
都有。好，好，我可以说 quiz two 的东西还是会出现，
一样难度很难。
不是，I mean 就是一样的方法和题目，就是
这样还好啊。
题目问不一样啊，好像是用一样。What do you mean? You want me to prove this? Seriously? Not in the Google of this class. You want to prove? Don't confuse you. Later. In the next rest, I prove. 10 minutes. But what you learn in this class is this series diversion because limit of a and 12 minutes. Okay. Later, next 10 minutes, I prove it. If you're interested. Since not all of you come, let's do one question first. Okay, while waiting for the rest, try and do this question. Whether the series converge or not. Let's remind us what we have. We have a geometric series, P series, test for divergence, okay, integral test, and whether direct or your not so call it or ordinal. Hey, what do you call it again? Ordinary integral. Yeah. Okay, so you need to recall any test or not? Forgot. Okay. Any test you want me to repeat? Yeah. Oh, okay, possible. Try. So geometric series is the form of adding 1 to infinity of a times Rn. Right, R is the ratio, A is the first term. So this thing converges. Yeah, maybe I put that. So this converges if if what? If the radius is in between 1 and -1. Okay. Yeah, so diverges otherwise. So if and only if. Change this color also. Okay, how about P series? So what does P series looks like? So it's 1 over NP. Okay. Notice that in the series, right, you must have this N because this N is controlling how this terms grow. Otherwise, you just get some constants. So this converges. When does this converges? If and only if P strictly greater than 1. Let's check. Strictly greater than 1. Remember how we check this? Use integral test, right? Remember, we use integral test to prove it. Okay. So actually, if only, yeah, correct. Okay. So how about test for convergence? So test for convergence is any series converges, then the limit of each term is going to be 0. So in other words, you can use the contrapositive. If the limit is not 0, then the series diverge. Okay. Integral test. So integral tests very important. You definitely need to check 3 things. So f is continuous, and then positive. Okay, positive means lies above the x-axis. Positive, and then decreasing. Okay, if it is not decreasing, there's no point to calculate it anymore. Right? Increasing, the area increase forever. So no point to calculate. So must be decreasing. Okay. So decreasing on the interval. Okay. Actually, this interval can change, right? Really, this interval can change as long as it is continuous, decreasing, and positive at the interval. Okay. So this one doesn't really matter, right? So can start anywhere. Yeah, can start anywhere. Should I maybe change it to A? There's this some A in in n is enough. N greater than 0. Okay, then what? Then the question on the series can be answered by the integral. Okay, so the series converges. And let me move this. Okay. So now I change to A, right? Yeah, too many A. So maybe I change to N. Then N clash again. So maybe change to P. So N equals to P converges if and only if the integral from P to infinity of AN. Is it good to write AN? Let me see what's the notation used. Okay. So let me remove this. So because we want to write as function, right? Okay. So this one decreasing is such that AN equals to FN SN for all n in. Okay, so this means that I make my sequence into a function. Okay, I want to check this function is continuous, positive, decreasing on certain interval from positive integer to infinity. Then the sum uh, the infinite series converges only if the integral converge. Okay, put x here. Converges. Okay, not that why I put fx and fn here. Okay, because fn here is just checking discrete sequence. Okay, but fx here make this fn into a continuous function. And then you can integrate the continuous function. Okay. Okay, so how about direct and ordinary scale comparison test? So you need to start with positive sequence first, right? Okay. So how does this bound help you to determine whether one series converge or not? Okay. So if the larger term defining series converge, okay, for example, if Bn, infinite series of Bn converges, then because An is always smaller than Bn, right? So Bn already converged for the series. Series of Bn already converged. Then series of An must converge. Okay, because every term in An is smaller or equal to Bn. If it's equal, then it's just Bn, right? Okay. Smaller, then must convert as well. because you are adding less stuff. Two is if the series of AN diverge, okay, then BN must diverge because you should think that it is at least as big as AN. If it is equal to AN already diverge, BN must diverge. Okay. So if it is greater than AN, it must also diverge. Hey, when can not here? When can ask me to do summary? Okay, we will do summary again. This is just first part. Okay. So we got so many 1, 2, 3, 4, 5, 5. Okay. So which one to use here? Ah, A. Why? Why is this a geometry series? Where's the geometry series? So we can rewrite this term here as 2 to the power n times 2 times 3 times over 3 over n, right? Okay, let me this. Okay. So if I write like this, sorry. What? Oh, huh? Oh, you mean here is 4? Wait. Oh, wait. What am I doing? Huh? Right. Okay. So it becomes 4 to the 4. Okay. So does this look like geometric series or not? Combine the power, similar power. Okay. So combine the similar power term. Right. So does this converge or diverge? Diverge. Someone say convert. Someone say diverge. Why converge? You say your reason first. Huh? Is it less than? What is less than what? Huh? 4 over 3. Okay. So it's 4 over 3 diverges due to geometric series as the ratio is greater than 1. Okay. Can you use other tests or not? Can, right? Okay. In particular, you can use test of divergence. Test of divergence. I think can test of divergence. Can, right? Test of divergence can. So okay, let me write here. This one is the geometric series. Geometry. So test of divergence, I think also work. Okay. Okay. So you just need to check the an, the limit of an. Okay, so what's the limit of an here? Because it's 1, right? You get infinity or not? Yes. So by test or divergence. So every time what test you use, right? Make sure you write it out. Okay, make sure you write out all the tests you use. Okay. By test of divergence, the series diverge. What else can you do other stuff? No. Hey, what? Elon. What is Elon? What are you trying to say? No, I mean you. And then
It's 0.2, so it's diverge. Okay.
Oh, you mean you want to compute this limit in another way? Is it?
Yeah.
Oh, okay. Oh, okay. So, okay. So, okay. So so your friend suggests that we can also compute this limit here, e to the ln 2 to the n 3 e times 3 to the minus n. Okay, so why is this useful? So he simplified this to 2n ln 2 plus 1 minus n ln 3. So in this case, you don't split this then. Okay. And then, so you group the n term ln 3 plus 2 ln n 2 minus ln 3n. This you take this limit to infinity. Okay, should be fine. Okay, thank you. Yeah, if you are doing this way also can. Okay, at least there's one more way I can think of. Can you think of one more way? Comparison. So what thing you want to compare to? What do you want to compare to? I mean, this form is easier to work with this form, right? This form here. Because you collect all the n together already. Okay, so comparison compared to what? Compared to? Huh? What? Don't know. So let's put here direct comparison or ordinary. Yes. Okay, maybe use ordinary then because your lecture not use this ordinary comparison. Yes. Okay, so what's our series again? 3 times 4 over 3 to the power n. Okay, so what can you compare to? 3. What do you say? Yeah, sure. How small? Cannot too small. Right, too small, then it converges. So you greater than something converge, you still don't know whether you diverge or converge. Right. So you want to show it diverge, you need to greater than something that diverge. If you are greater than something that converge, you don't know whether you converge or diverge. Right? Make sense? Okay, so how? 3. Okay. Because this is greater than 1, right? Remember the ratio is greater than 1. In particular, we just pick 1. Remember the series of 1 diverge? Yeah, diverge. Okay. So we can consider we can consider 3 1 to the power n less than equals to 3 times 4 over 3 to the power n. Okay. So by ordinary comparison test, since the infinite sum of 3 times 1 to the power n, actually it's just 3, right? Okay, so this is just 3. Sum of constant number 3 diverges the original series also diverge. 2 to the 2 and 3 to the 1. Okay, so this is the third way. So in principle, one question could have many ways to solve it. Maybe one is obvious than the other, or one is easier than the other. Okay. Later I'll post out the tutorial question, then you can try it yourself. And then you will notice some pattern when you do this question. So sometimes when you see this kind of pattern, this test is more preferable than the other when you try and do the tutorial question. Okay. But I think hopefully today I will teach you one very useful one, at least for me, when I learn this thing. Hopefully we can finish this chapter by next Wednesday. Hopefully, yeah. And then on Thursday, if I can prepare some question, or you can ask some question for revision. Yeah, yeah, right. Okay, yeah. 4 to 6 tomorrow, right? Tomorrow 4 to 6. Oh, is it 4 to 6? Or 6 to 8? 4 to 6, huh? Okay. 4 to 6. 4 to 6. 4 to 6, right? What's the venue? A4G07. Okay. A4G07. Tomorrow, 4 to 6. Okay, so we will learn new stuff today. So new material. Limit comparison test. Okay. So similarly, we also start with two positive sequence. Okay, but there's nothing relating these two. Never mind. We don't know what happened between them. Between them. So they need to be positive. In particular, Bn, okay, An can be non-negative, but Bn must be positive. Why? Because we are going to divide the terms in the series. Okay, so we want to divide the terms in the series. Hey, when can we just finished doing summary? Oh, okay. So we consider the ratio between the every terms. Okay, A1 and B1, A2 and B2, A3 and B3, A4 and B4, A5 and B5. Okay. So what does this limit tell us? Okay. So if this limit is finite, okay, if it is finite, then these two series are comparable. Okay, they either converge together or they diverge together. If L happens to be 0, okay, happens to be 0, and the denominator, the series defined by the denominator converges, then An converge. Okay, think a little bit about this test here. Can L be negative or not? Why? Yeah, because the An and Bn both positive, right? You cannot go to something negative, right? So the smallest number you can go is 0. Okay, so let's say the number is 0. When does the number converge to 0? What kind of sequence converge to 0? What kind of sequence converge to 0? Yeah, you go very small. Okay, as small as possible. So how you go to very small? Your denominator must be big. Okay. So your denominator must be big. So if the big thing converges, so the small thing also converge. Right? Okay. I mean, this is one of the idea you can think of it, because this is not how we prove it. But it's similar. Okay. So if L is any finite ratio, then they converge or diverge together. Okay. 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 So let's see how to use this. Okay. So let's say we're given this sequence here. So how are we going to use it? What kind of sequence we can pick to compare to this sequence here? Okay, so one trick here is when you look at this polynomial, right? Okay, so polynomial, what control the polynomial? The degree of the polynomial control the polynomial. So for example, x plus 2, there are no much difference between them, right? It's just shifted y equals to x. Okay, so really we just really care about the highest degree of the polynomial. Okay, so you can really it is about the same as, so this sequence here is about the same as 3n over n cube. Okay, about the same. Okay, so what is 3n over n cube? 3 over n squared. Okay, so 3 over n squared is convergent or divergent? Convergent. Why? P not power series, P series. The P here refer to the P. Okay, refer to power, sure, refer to a power. But later we will define different power series. Okay, so this is converge due to P series. Okay, because 2 is greater than 1. Okay, greater than 1. Okay, so this converges. Okay, so if we're gonna use this, if we are going to use this limit comparison test, we know that 3 over n squared series converges. What should we get? When we take the limit, it should be finite or it should be 0, so that we can deduce something for the original series. Okay, so what should we do? So first of all, is this positive or not? Yes. Is it easy to see? Okay, if you want to check, right, you can just check whether this is, so I let you check. So check whether these are true. These are okay. So check when these are true. So check the numerator is positive, denominator is positive. Okay, I think n should be greater than 0. Is it true or not? Okay, so let's check. I'm a bit skeptical. So 3n must be greater than 2 over 3 here, so 1 works. The n cube one. Okay, I'm a bit lazy to check, so just check by substitution first. So if I substitute n equals to 1, what do I get? 1 minus 2 plus 11, which is 10 greater than 0. Okay, should be fine, right? Is it fine? Yes. Okay, I mean, okay, really you need to check here. So I leave you to do some check. I think you need to factorize or what, so that you can see it. Okay, so let's assume that so assume this 3n minus 2 over n cubed minus 2n squared plus 1 is greater than 0 for all n greater than equal to 1. Okay, and we know that 3 over n squared is strictly greater than 0, okay, for all n greater or equal to 1. Okay, this one good, this one we know. So we need to compute the using limit comparison test. What do we need to do? We just take the quotient between an. Okay, so I need to set my an to be 3n minus 2 over n cubed minus 2n squared plus 11. And then my bn is 3 over n squared. So let's do this. So we need to divide these two terms. And then compute the limit. Okay, so how we divide these two? What do we get? Okay, so we can, what can we do? We can just multiply in, right? Okay, so swap the fraction. 3n cubed minus 6n squared plus 33. Okay, so can you compute this limit of this sequence or not? Huh? How to compute the limit of this sequence here? Divide up and down by 1 over n cubed, the highest power. Okay, so we get over n 3 minus 6 over n plus 33 over n cubed. Okay, which is just what? 3 over 3, which is 1. Okay, so 1 is in between 0 and infinity. Okay, so 1 is in 0 and infinity means if the series of Bn diverges or converges, then the series of An diverges or converges. So in this case, Bn, the series of Bn converges, so the series of An also converge. So by limit comparison test, since E over n squared converges, the original series also converges. 3n plus 2 over n. Okay, so when you see this, always when you see this polynomial, right, think of the highest power term. Okay, think of the highest power term. Okay, it's almost the highest power term. Almost. Okay. How about I let you try B. See what kind of Bn you can find. You try B. 1 over square root n squared plus 19. So when you see this polynomial, right, think of the highest power term first. Okay, it is approximately the highest power term. Okay, compared to that first. That's the first choice you should make. So n squared plus 19, what's the highest power term? Okay, too fast. Let me just ask about n squared plus 19. What's the highest power term in n squared plus 19? Yeah, n squared, right? Okay. So you compare to 1 over square root n squared first. see if you can find something useful. So set an to be 1 over square root n squared of 19 and bn to be 1 over square root n squared, which is 1 over n. So 1 over n diverge or converge? Diverge. So see what's the limit between these two. Remember, always place the terms, the series that you want to find at the top. Okay. The thing that you now put at the bottom. This is the trick of this theorem for test. Okay. So how to compute the limit of this sequence here? Huh? How to compute the limit of this sequence? How to compute the limit of the sequence? Divide by 1 over n, top and bottom. Where you get 1 over square root 1 plus 19 over n squared. Okay. Hi. What? What's going on? What's going on? Hello? What's wrong? 1 over n squared. I multiply top and bottom 1 over n. So you want to move into square root, right? So you become n squared. Okay. What's this limit here? 19 over n squared. Converge or diverge? Converge, right? Converge to? Converge to 1? Say 0, right? Converge to 0, okay? So you can use the limit, the property of limit, then you can bring the limit in, and then what can you do? You get 1 over 1, okay? Which is 1, okay? So 1 is in between, is a finite number in between 0 and infinity. So if Bn, the infinite series Bn diverges, then An also diverges. Converge, then converge. So, so by what? A limit comparison test. Okay, when you see this comparison, right? So you need to have two series to compare. Okay. So by since what? Since the series of 1 over n. What is the series of 1 over n again? There's the name for this. Harmonic, okay, harmonic series. So harmonic series converge or diverge? Diverge, right? Okay. Since the harmonic series diverges, So the original series also diverge. Diverge. Okay. Yeah. Let's do one more. Then let's do one more, and then we take a break. Okay, I let you try this. So let you try for 3 minutes. What's the BN you can pick here? Okay, because this is an example under limit comparison test, right? So we want to try if we can solve it using limit comparison test. Maybe you also can solve in other way, but let's try if you can find some BN that is useful. Try you can find some BN that is useful. So now here, right, both of them are already highest degree. Okay, log n is not polynomial. Well, so what to do? Anything you guys tried? Any BN? Any idea? Any idea? One over what? One over log n. Do you know one over log n converge or diverge or not? One over log n converge? Let me see. One over n squared. Okay. How about we try? Okay. One of you suggests this. So let's try this. So what is so an is log n over n squared. Log n over squared over 1 over log n. Hey, then you get log n squared. Is it? You get log n squared. Log n squared. So what you want to do? You want to do L'Hopital to compute this limit, huh? Right? So you get 2 log n, 1 over n, n. Is it? Differentiate log n, you get 1 over n or not? Okay. So you get this. So you want to do again, right? You need to do again. N times 2n. N times 2n. N times 2 times n. No, I mean the first n is coming from chain rule differentiating from n squared. Right? Right? Yeah. Okay. So 2 over for n squared, is it? Yeah, because chain rule drop the n again, right? Okay, so this is 0. So you need to say that Bn converge, only An converge, right? Because this limit is 0. So does this converge? So does this Bn converge or not? So to see this converge or not, I think it's easiest to see from the integral test, right? Because this is a function. You can define the function using one over ln x. So this one converges if and only if the integral from 1 to infinity of what's that? Fx, sorry, ln x dx converges by integral test. Okay. Okay, so you want to use integral test. So you need to make sure this is a positive ln x. Question? Any question? One question. How do I get 2 over 4n squared? Okay, so so we first start with 2 times ln n over 2n squared, right? Okay, so we want to differentiate top and bottom, right? So if you yes. So I differentiate the top, I got 2 times 1 over n, and then bottom I got 4 times n, which is equal to the thing inside here. Okay, so we want to check this ln s is positive, continuous, and decreasing on the interval 1 to infinity. Okay, so is this positive? Positive, right? Ln 1, ln 2, ln 3, ln 4, ln 5. Okay. Continuous at 1. Is it continuous at 1 to infinity? So this is positive because 1 over ln n is greater than 0. Sorry, should be ln x, or in 1 to infinity. How about continuous? So ln n not continuous at n equals 0. Yeah, so it should be fine. So this is continuous. This is okay. Is it decreasing? So we need to check what is f prime x. Okay, so we need to differentiate our ln x dx of ln x, 1 over ln x. So how to differentiate this? Want to differentiate this. Product quotient rule, negative. Quotient rule. So what is quotient rule again? Vu prime minus uv prime over v squared. Vu prime. So I mean this is u over v prime. So vu prime, so it's 0. So uv prime minus u times 1 over n over ln, sorry, x squared. So what's this huge term here? So 1 over x times ln x squared. Okay, just now we says that, so ln x, everything square, sorry. So just now it says that 1 over ln x is always positive. In particular, 1 over ln x squared also positive. And then x is always positive because it's going from 1 to infinity. So minus a positive number is always negative. Oh, okay. The thing is less than 0 for x in 1 to infinity. Okay, now next we want to check the integral. So what's this integral? Does this converge or not? Okay, so not that this is an infinite. I mean, you need to integrate until infinity, right? So if non-infinity doesn't define, so you need to use in exam, you really need to write this. So you need to do the improper integral, okay? Because you need to integrate until somewhere that is infinity. Improper. You must write this. I'm giving you tips now. You must write this. Huh? What? Why exam then become attentive already? You need to write this. Okay, improper integral. So solve this as an improper integral. So 1 to t ln x dx. Okay, so what's this? Ln x, integrate ln x, what do you get? Hey, integrate ln x, what is that? What's ln x? By part, ayo. Also tired. Okay, you got formula or not? We can say by part, but got answer or not? Or we want to do by the formula or not? Try if you can find the formula. Oh, huh? What do you get?
X minus X.
X ln x minus x plus cc, never mind. Okay, so this one, we skip it, so go back and do by part. Okay, do by part. Huh? I don't think so. Don't think so. Don't think so. Because you did this by part only do twice, I think. Once. I think once enough. Seriously, by part is a skill you need to learn. I'm just being lazy only. You also lazy. I mean, if you already know, then you can be lazy. Huh? I don't lazy too much. No lah. I mean, exam need to test whether you know or not. After you know, you can be a bit lazy a bit. Okay. So, what to do? Okay, what to do? Yeah.
Right, due to
What?
improper integral.
You mean this step, huh? Yeah, you have to write. Which one? You can write it. If you don't write it, we also understand. But why not write it if you know? Got lah. Got. Got. Okay. T ln t minus t, and then minus plus 1. Okay. So what do you get? Don't you get infinity here? Get infinity, right? Yeah, this one is infinity. Infinity or this? This is infinity, isn't it? Oh, wait. We have an infinity minus infinity. So what's going on here? Huh? 0? Wait, this is weird, huh? Can use anything or not? Not sure can use anything or not. T times ln t minus 1 plus 1. We use anything here? Yeah, infinity times infinity. Wait, let me see. Huh? So what's going on here? So let's try. So ln t over 1 over t plus 1. Wait, now can use L'Hopital, right? Okay, now can use L'Hopital. So let's do L'Hopital. right? Because top go to infinity, bottom also go to infinity. Okay, so we can do log beta. Yeah, I think it's good now. So the top will become 1 over t, right? And the bottom will become minus 1 over t squared. Is that right? Okay, which. So what do we get? Become infinity. Infinity here. Let me see. What? No. I mean, we can multiply, right? And please check my working. Is it correct or not? Infinity is something wrong. Huh? Say, huh? I know. Wait. So here, wait. So okay, let me check. So here is infinity, right? The bottom is 0. Oh, the bottom is 0. So how? What next? I don't sure. So how this? Okay. So let's keep this limit here. See what we can get next time. Okay, try compute this. Okay, so this question, right? This question, you can do try bn equals to 1 over n 3 over 2. Yeah. I don't know. Okay, it's like this. Okay, I can let you see. So if you try another b, okay, maybe you also try a few. So try cn, which is 1 over n squared, and then try dn, which is 1 over n. Okay, you try these two. So one of them you will get infinity, and then one of them you get 0. And then you go and pick something in between. Then somehow it works. Right. No. I mean, wait. Huh? Sorry. No. What you care here is the limit, right? Here is limit comparison test. You don't need to compare two. Okay, you compare two sequence using limit. Right? You take a ratio between a and bn. Correct? Yeah. A and bn is 0. Okay. But when you get 0, right? Okay. But this thing diverge, so you cannot deduce anything. Right? Remember, when the limit is 0, the bn must converge, only an converge. Okay, so this 1 over n diverges, so you cannot say anything. But 1 over n squared converge, but the limit is infinity. You also cannot conclude anything. Okay, so you need to find in between 0 and infinity, right? Right. Your L must lie in between 0 or infinity.
So this question is 3 pages long.
This question is quite tricky. Not to say unreasonable or not, but you need to learn the trick, right? Sometimes. Yeah. Okay. Huh? Sure what? I mean, not sure the correct one. I mean, in real life, right? There's no correcting one. Nothing is correct. Just workable or not. Yeah. Okay.
Then you give me 100 marks. Then I write 1 for every single answer.
You sure, right? Okay. Okay. Hey, I seriously think that this should go to 0, but not sure how to do it for now. Yeah. Think about it first. Huh? What? 什么？没有 I mean, I think can, but we don't want to waste time here first.
You waste time.
Okay. I think this will work. Later we will see. Next class, I will show you. Log n. I think it will work. Yeah, you just type this into computer. Go symbolic alpha Wolfram also can go and type it. Type this, what do you get? Huh? Yeah, I mean, you already, yeah, it's the same. So what you get? It's divergent. Divergent. I mean, this integral here, diverge. Diverge, then no use. If diverge, then no use. No. Yeah. If diverge, no use. Diverge, then no use. Because your limit is 0, Bn diverge, you cannot conclude anything. Limit is 0, Bn converge, then An converge. Yeah. If it is, then no use. No use. Okay. Yeah, you can prove it. So in this case, it's really infinity then. So no use. Okay. So we conclude here, no use. So this Bn, no use. Bn doesn't work. Doesn't work as integral. Converge or diverge? Which one? 1 over ln n. Yeah, ln n over n square converge because I already asked you to use this Bn here. This Bn is a P series, right? This Bn is a P series. So P series 3 over 2 is greater than 1. So converge. 3 over 2. 3 over 2. Hey, just now your friend already asked already. How are you supposed to find 3 over 2? Right? Just now. So practically how you do, first maybe you take 1 over n squared test first. Okay. And then you reduce by 1 over n. Doesn't work. In between 1 and 2. Sometimes like that one. Okay. Yeah, sometimes. Okay. You give up. Okay. Any other question? Any other questions? Huh? What do you mean? Not examinable, right? A similar question will be. Okay. Yeah, similar. Okay. Okay, let's take a break. 916. Huh?
是不是啊？
Yeah.
然后我下面等我一下，这两张啊，这两半的。
如果我写成这个是不是比较清楚一点 ？infinity 乘 infinity， 因为刚才我们有 infinity 减 infinity。哎，我们这边本来有 infinity 减 infinity， 所以这里不是很明显。
哦，我知道，但是我的是
像这个应该就比较明显。
对啊，那这个还，那这个刚刚为什么你们还要用洛必达什么的？
因为我们没有看到，很简单的吧？我们没有。你刚才看到，你应该跟我们说。
我以为这不就是
我们没有看到，对，我们没有看到。
infinity time infinity 了。
对，呀，就这样，没有什么奇怪的东西，没有。
然后还有就这个能解释一下吗？但是有点混还是没就是为啥它一定要大于等于2？这个结论
这个是它的，我们没有仔细说它结论怎么来，我们只是说它之间的关系吧，因为我们没有证明。我们没有证明，我们要证明是，我们没有证明。
所以你
我们没有证明。我只是大概解释一下怎么记这个东西。我们没有证明。
会证明。好。
不会。
所以说，你刚刚解释一下说它要大于等于。
为什么呢？没有讲为什么，但是我们一开始就要求它大于等于0，这个要大于等于0。但是为什么这个大于等于0？是因为我们要不可以等于0，因为我们要除。对，就只有这样吧。我没有解释为什么我们 start 会大于。
所以这整个都没有解释。
我只是解释让他们知道怎么记这个东西，比较容易记这个东西。 怎么记？怎么记？就是，如果这个 L 是一个 finite 的 number，就是意思说 AN 跟 BN 被控制在一个 ratio 那里，所以一个大，另外一个也大，一个 diverge，另外一个 diverge，一个 converge，另外一个也 diverge，因为它被控制在一个。
刚才讲这个
但
问题，
是如果
等一下，
但是如果这个 L 是0的话，意思说你的 BN 是大过你的 AN 嘛，它才会去0，对不对？因为你的 sequence 越来越小，越来越小，越来越小。你的上面越来越小，或者下面越来越大，对不对？OK，所以你看下面如果越来越大的话，它 converge 的话，下面大的 converge 小的也要。这种国家我们怎么记的？耶，但是 proof 是没有。
你给我展示你的答案，你不要这样子直接单评啊！我要看你的图表，或者你重新放一遍。
哪个？哪个？哪个？
就是说，那你现在讨论好吧？现在讨论。
对。
然后你做F test 的时候，为什么只用下面的部分？但是如果你用里边做一个肯定就是
哎，对咯，怎么没有人查这个东西？我做错 interview。
对啊，你为什么否定了？
那你做没有讲？
怎么没有讲？今天不要讲，我写错了。
哪里？
老师不可以，老师你是老师。
不是这样，老师有一个关键问题，
你可以相信我，但是你要自由。啊？
我
没有，我没有做梦，我只写错罢了，我 seriously 写错。对，
你自己写错。
所以我只是
故意啊！
我没有故意，你问我一下，我没有故意。
哦，老师故意老师。
所以这个算出来是什么？哎，所以刚才点的那个 computer 是点什么？
点是 computer，
那你算的那个
这个啦，
这个是什么？这个算出来。忘了我那个 x 也是by part 算的，所以要算出什么东西？
啊，不会啊，加油啊！
算一下，会不会比较容易看？
x3 over
把 non xid
直接 type 哦。
就是我就问一个问题，你讲考试的数这样类似，什么东西会类似 improper integral 啊？
对。
哇，我很久
integral test 吗
improper
没有很奇怪的，就是只是把那个你平时放号码嘛，只是现在放一个 t， 然后你用里面。
我突然觉得我的这个是好。
你要写这个啊？你要写 im，
我已经懵了。
哦，很久
要讲，
我有没有做 improper integral？
真的刚才拿到什么？
啊 ，non 喂。
integrate f 跟 x 3 over
这个对。
不是可能。
那
你 let b let u 等于 log over log x。
什么是一啊？
哦，那个算不到的，那个
收不到。
是。
one over log x 讲 differentiate，不可以 differentiate。
可以 differentiate。
one over log x 哦。
我刚才不是 differentiate 出来了？
哦，全部。
我不是 differentiate 了。
啊。
微分的话基本都能微的，积分有些时候记不出来，你微分怎么微？
integrate 不了。
integrate 不了。
integrate 不了。
哎，金花，刚才 integrate 错了。integrate one over log x 怎么 integrate？
integrate 不了。
我没有在听。
哇，
怎么 integrate？ 来拍一下。OK。对。没有解释。
我想不到。
没有解释。
我以为都是我上课没
解释。
你想一下。
所以就是要硬记了。
可是
因为我看到
你想一下，有什么可以 differentiate 变成1 over？
对。
因为我看不懂。
啊，你看不懂哈？
他看不懂，他怎么就来到这个
？OK， 这样的话应该可以大概跟你说一下。因为啊，
一个东西吧，你又少一个东西割掉，你的东西
你要是讲
你算不到了，你 x 还是在。
对 i 在哪里？对 i 是 s 减 sn。什么是 sn？ 什么是 s？s 是这所有的 box 加在一起。n 比如说，假设这个是1吧，好吗？假设这个是1，可以吗？我们就第一个、第二个、第三个、第四个这样下去。OK， 所以假设 S1的话，就是剩下的咯，因为 S1是第一个嘛。
指的前面，从左边看，先
对，这是第一个，对不对？对，所以 R 是这些剩下的东西。
这什么意思 ？lin x。
所以你可以看到的是什么呢？ 这一整串的东西是小于你从这里 integrate 到你看看，
不知道，
啥
你变吗？
啥，所以你要把这两个不是想成
model y 就变为
那个 area under the ground，
x 一
哦
啊
，RN
对
是RN 关于这一块嘛，
那
就是
1 over x
蓝色的
变到 x 种，
就
然后
蓝
是1
色
over
就是
x
要
1 over
小
x
于这一个，
加一多一个减，
那它大于
算不到
，n 加一
算不到，
的，
算不到
但。是它 assume 老师 assume log is natural algorithm，
然后呢，
但它是 integrate does not conversion，
does not conversion 是 does not conversion，
does not conversion。
does not conversion， 白怕的，
log x 变成 like
越来越大。是这样，我也
你不可能让这个 integrate 嘛，因为你不能 integrate 嘛，所以你只能 differentiate 它
放弃是一种选择。
那你也不能继续 integrate，
因为这个 B N 就选错了呀。
就可以 integrate。
对呀对呀对呀，
哇，你好厉害耶！你好厉害，
对对对，
你
我知道。那怎么办？
靠，每天这个每天讲那种很恭敬的话了，你很厉害，你讲到有时候我都飘啊，
就是
我都以为我给
你这些，
他就讲啊，原来我
就是
会
怎么想呢？就是
哪一个？
就是类似于用这种
哦，这个我刚才是说你
说我的意思是说你怎么想呢？就是处理这个方可以噻。
没有，刚才我有解释怎么找这个，就是
给
打最大的那个考虑最大的那个，
对啊，
对，
但是你这有没有理论啊？
有没有理论？
对对，
理论就是他们
就是有没有 theory 上面？
有
是别人吧？
不是
你去跟
I
我
mean
可能没有，但是
没有，
这是什么？如果这个东西converge 了，
他的 statement 就是他的 statement 就是3n 减2 n 非常大的时候，它
这个
和
L
3n
我这一个是
差不多一样的。
这个是
OK，我理解你意思。
老师刚不是有提到一个？
那你这个
这个
就是
这个
2/3，你这个
刚才有解释，就是说，假设啊，你去试到这个 n square， 因为它这里有 n square 嘛，你的想法应该会去试 n square。你试 n square 过后，它去你家就没有用了，因为你没有。那你就想，哎，我如果下一个呢？下一个就是 n 嘛，下一个 n， 然后我就试一下了，哎，它去0哦，但是问题是它是100%，那也没有用。所以你看，它这个 limit 是 in between 0跟1。
这个
所以你会想一下，试一下我调
没有上
一个
课的对吧？
好，
你这 dn 的话，体现不应该是0。
如果 B N 等于然后 B N 等于0，
然后你再去算，你会去哪里？
哦，就是
log n over n square over e over n square， 然后你会找到 log n。
带过去，sorry，
是哪个？
带过去
log 你拿 limit of log， 你拿 limit of 这个东西，
我知道，
不能往，它只能往后的，不能，谁往，你只能跟着这个顺序。你要先知道，
不是说这个 n 方面之一这个
它这是另外一个 variation。
不是。
如果你算这个零
，OK，对，不是，对，是。OK，可以，我要开始了。OK， 快来。有什么？等一下再，因为这个有一点，你看到了啊 ？OK， 你看到了 ，OK。对。
还有来，都是老师在讲，让奇怪，我可以写一个。
可以。我写 L， 我是写 L， 其实。可是那个 I 很像 L， 你写 L 又很奇怪。这个你看，它是你去是不是长这样的？是长是 L， 但是写的时候不一样哦，是这样买啊。有些课本好像是这样，但是有些书是一点点这样，它是这样。写吧，我应该知道你在做。呀，可以，写。那只是我很担心吧。OK， 都可以。你不要写1就可以了，我不知道什么是1。OK， hey, where is my attendance list? Got hijacked already. I bring. OK. Hey, so today 紫糖看嘛？紫糖哈，紫糖对吗？ 子涛，方舟哎，方舟 missing on the way toilet。啊，轮流啊 ，take turn 啊。Okay. Okay. So before we go to the new stuff, right? So let's clean up what we did just now. Okay, just now we integrate the wrong integral, right? So we should integrate 1 over log x. Okay, and then it seems like we don't know how to integrate this. So this integral diverges using computer helps. Okay, so just now there's some confusion here. So what's this limit here? So what am I referring to this limit here? This is the limit of an over cn or bn. Okay, please don't confuse. I'm not looking at the limit of the sequence, but the quotient. Okay. Yeah. Please don't confuse. Yeah. Yeah.
我想问啊，
Yeah.
两个没有关系的，根本没想。
Because of the limit, right? One of the limit going to 0, one of the limit going to infinity. So your L, if it is in between 0 and infinity, then you are done, right? Huh? Wait. So come back to this picture here. So you see, just now, one of the limit is 0, one of the limit is infinity. So if you can find something in between, right, then you can use this result here. I don't know, so you need to test. Maybe this is the worst case. Worst case. Worst case.
Teacher like to do the worst case scenario, right?
I don't know about the rest, but I'm the one. I'm one of them. Okay. Yeah. Any other question? Any other question? Okay. So we go to new stuff. Okay, so next we will deal with alternating series. So what is alternating? So you have alternating sign plus and minus in front of your sequence. So for example, what? For example, 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1. Okay. Okay. So keep going. This is an alternating series. So does this series converge or diverge? 1 plus minus 1 plus 1 minus 1. Diverge. Depends on. What do you mean my last term? My last term is at infinity. Where's my last term? But 1 minus 1 so 1. So S1 is 1, S2 is 0, S3 is 1, S4 is 0. So this sum converge or diverge? Because what? So you consider the sequence of Sn, right? N partial sum. So you go between, so let me draw. So you go between 1, 0, 1, 0, 1, 0, 1, 0. Okay, so this sequence, the limit doesn't exist. Okay, so some diverge. Okay, right? Okay, okay. So we got a test actually. So let's say you got this alternating series. You just need to check two properties, okay, to see the series actually converge. So one property is the term decreasing. Okay, Bn is greater or equal to Bn plus 1. This is the usual thing, right? You want the every term to decrease when you add them together in the sum. Okay, but how fast they need to decrease? The limit of Bn have to go to 0. So meaning what? Meaning your term must be like, although, okay, let me draw it. So here is positive, here is negative, here is 0. So you must be like getting smaller and smaller and smaller and smaller and smaller and smaller. Okay, so that when you add up, it is 0, converging. So notice that this B, right? Okay, I already take out the alternating sign. Okay, so for this Vn is all the positive number. Okay, so this B is the positive number. We already take out the alternating sign for B. Make sense? Make sense or not? So for example, okay, for example, in our example here, this example here, okay, this example here, what is Bn? 1, correct? So Bn is 1. So this one diverge. Okay, so Bn is 1. Okay, and then limit of Bn is just 1. Yeah. Okay, so Bn doesn't read the alternating sign anymore. Okay, understand or not? Okay, let's do one example. Okay, do one example. Doesn't really understand. So let's do one example. Okay, moreover, there's a line here. We can bound our remainder by Bn plus 1. Okay, you don't need to know why. You can use it first and then later you can ask if you need. Okay, so let's see how to use this. Okay, this is a classical series called the alternating harmonic series. So harmonic series is all positive. So now we introduce the alternating sign. 1 minus half plus third minus fourth plus fifth minus 6. Okay. So we want to show that this actually converge. So harmonic series diverge, but if you introduce this alternating sum, it actually converge. Okay, so this is the thing you need to know. So we are going to use alternating series. So what is our Bn in this case? Our Bn is just 1 over n, right? Okay, because alternating harmonic series is 1 to infinity of minus 1 to the power n over 1 over n. Okay. So first thing you want to check, what you need to check in alternating series test. Okay. Series test. So when you want to add numbers, right? Okay, you want to convert. So the thing you need to add must be smaller and smaller and smaller. So it makes sense to say that, to check that Mn Bn is greater or equal to Bn plus 1 for all n greater than 1. Okay. Okay. So how to check this? To check this. So you need to check whether 1 over n is greater or equal to 1 over n plus 1 or not. Okay. So if you want this is true, then you need to make sure that n plus 1 is greater or equal to n. Okay. Which means that 1 is greater or equal to 0, which is true. Another way to see it is because n is positive, right? Okay. So n plus 1 is greater than n. So 1 over n is greater or equal to n plus 1 over n plus 1. Okay. So 2. For 2, you need to check that your Bn really converge to 0. Okay. So how to check Bn converge to 0? I think in this case is quite straightforward. So limit of n to infinity of 1 over n is just 0. Okay. So you already checked these two satisfied. So by alternating series test, the alternating harmonic series converge. So alternating series, you need to check two things. So alternating series only work for alternating series.
Why not the power is
Why not the power is
when power is n-1?
Oh, I think n minus 1. Correct. Yeah, n minus 1. This one. Okay. Minus 1. Because you want to make sure the first term is positive first. Negative. Okay. Hey, actually, there's one thing to note here, right? Last time we said that the limit of sequence equal to 0 doesn't imply the series converge, right? But in this alternating series, right? If it is alternating, add another condition, Bn is greater or equal to Bn plus 1. Together with that, the test for divergent condition, then we can actually see that the series converge. This is the idea of this alternating series. Huh? Yeah, only for alternating. No. Yeah. So you need this alternating. So the negative help you to cancel something. Cancel the sum. Okay, very good. Cancel the sum. Right. Because last time you remember in the harmonic series, when we add up, right, it diverge. Okay, but when you add this minus sign, right, somehow it keeps help you to take away some positive number. Okay. Okay, so I let you try this. Okay, show that this converge using the AST alternating series test. I think alternating series test is easier to use because it can only use on alternating series. So if you see alternating series, the first thing you should try is alternating series test. Okay. So to use this alternating series test, right, you need to identify your Bn first. What's your Bn in this case? What's the Bn? 1 over n factorial. Okay. So is it true that 1 over n factorial greater than 1 over n plus 1 factorial? Okay. So this is true because n plus 1 factorial is greater than 1 over n factorial. Greater or equal, right? Let's see. Which is what? So this is true. It's true. And second, you check the limit, which is also going to 0. Okay. So you can see that this question, right? What's the difference between this question and the question before? You put a exclamation mark beside your n. I mean factorial. Okay. Instead of n, you consider the factorial. Exclamation mark. Understand? Okay. So by AST, the alternating 1 over n factorial series is convergent. Okay. Should we try one more? Do you want to try one more? Try it. Okay, one more. Let's see which one is better. Which one? Okay. Oh yeah, okay. Right. Ah, right. Okay. Yeah, something wrong with my previous note. Need to change. Okay. Hey, by the way, if if minus 1 to the n minus 1 converges, minus 1 to the n also converge, right? You just multiply minus 2. Yeah. Okay. Makes sense, huh? Okay. What? So minus 1 to the power n minus 1 series converges. Minus 1 to the power n also converge. You just multiply with minus 1. Okay. Okay, maybe try this one here. Try this one here. Huh? How about this one? Converge or diverge? Yeah. What do you mean? So this one start with this, then start with this one. Okay. Yeah. Should be okay, right? Yeah. As long as it's 1 minus 1 plus. Yeah. 1 plus 1 minus 1 minus. Bang, okay, you cannot reduce, huh? Huh? This one, you mean this one? You mean this one? Okay, let's try. So Bn. Okay, so let's try. So you want to try if 3n over 4n minus 1 greater than 3n plus 1 over 4n plus 1 minus 1. Okay, so the way I check it is okay. So you get 3n greater than minus 3n, which is what? Zero is less than minus 3. True, huh? True. Okay, true. It's true. Okay. Okay, this one okay. How about the next one? Why? Not equal 0. Okay, so not equal 0, so what to do? Convert. Not equal 0 cannot converge anymore. I mean, you cannot use this to show that it converge. Cannot apply. Cannot apply. Just mean cannot apply. So what to do? Life is hard. You see, so many don't come, then that's mean life is hard. Or maybe it's easy, huh? Because still at home. Okay. So not equal 0 cannot use. So how? Okay. So let's look at what happened to all the terms, right? So let me make all these smaller size. Okay. So what to do? So cannot use AST. Okay, cannot use AST. So what to do? So limit. So we can study what happened at very far. Okay. At very far, what happened here? What? So you can see that at very far, this term is actually alternating between 3/4. Okay. So at very far, it's just minus 3/4 plus 1 plus 3/4 minus 3/4 plus 3/4. What do you mean by so? Yeah. At far terms, the quotient limit to 3/4. But the minus 1 is just keep alternating. 1 minus 1, 1 minus 1, 1 minus 1. Right? Okay. So this term here alternates between minus 3/4 and 3/4. So at very far, it behave like 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1. Yeah, that's right. That's right. That's right. Yeah. If you happen to see, oh, I know that this doesn't converge because of this. Sure.
The first one is right.
No need to write. No need to write. Yeah. No need to write. Because no use already, right? No point to check. No point to check anymore. But let's say, for example, let's say if you want to use, you check it, then this is the way you check it. Okay. Okay. So because it's alternating between minus 3/4 and 3/4, so the limit doesn't exist. Huh? What? Does not exist. Okay. In this case, because you are calculating the limit of AN, right? So you can use the test for divergence. Okay. So by test for divergence, the series diverges. Okay, so divergence, right, is really convenient if you know what happened to the limit of your AN.
So technical part one.
You check what?
Check the true.
True or false? What do you mean I check true or false? You mean this one, huh? If how to say that? So you mean if you don't provide the bottom one, you provide this only, is it? Then you're stuck here. Then this one normal because this is the correct answer already, right? But let's say you work out this, okay, and then you stuck. You don't know what to do, okay? For me, I'll give some, yeah, one like that, 1 or 2. Yeah, depend on the quest. How long is the question? At least 1. Yeah lah. I mean, it is better that you write something down in the exam, okay, to show that you know something, right? If you put blank, then what do you know? Yeah, right. Okay. Yeah. Okay. The next one, let's left this as an exercise work. So let's do the next thing. Okay. Our series. Huh? Okay, so find the sum of the series correct up to decimal places. Okay, so you want to find the sum that approximate the real sum. Okay, so use the alternating series, right? You can check that x minus xn is less than bn plus 1. Okay, this is no. This is known. Okay, this is you need to know. Okay, you need to know this. Okay. So what n you pick so that you can approximate your actual sum up to 3 decimal place. So recall what is this? This is the alternating series for 1 over n factorial. Just now we showed that this converge, right? Okay, just now we saw that this converge. So this is a finite number. S is a finite number. So we want to find the sum, okay, what Sn that give up to 3 decimal place accuracy. Okay. So which means we need to find n such that x minus Sn is less than 0.0005. Why 0.0005 instead of 0.001 or something like that? Huh? We need 3 decimal place, right? Why we need up to 0.0005? What's 3 decimal place? So for example, 0.001, 3 decimal place. Okay. So why we need to bound to the 4th decimal? Because if you have 0.0005, you can correct to 0.001, right? If you write in 3 decimal place. Right, so you got the extra one popping out. Huh? What? Yeah, we don't want the extra one. Yeah, so that's why we make sure it is less than 0.005. Okay. So so how to bound this term here? Any idea how to bound this term by 0.005? How to find n? We don't know x, right? We don't know x for the moment. So if we don't know s, we can work out xn, right? You just compare what is s1, s2, s3, but we cannot. We don't have s unless you have s. Okay. So what to do here? What to do is we know that. What do we know? What do we know? What do we know? What do we know? We know that x minus Sn can be bound by Bn plus 1. So we just bound the Bn plus 1 by 0.005. We can bound the difference. Okay. Do we know what is Bn plus 1 in this case? What is our Bn? Our Bn is 1 over n factorial. Okay. So Bn plus 1 is 1 over n plus 1 factorial, less than 0.005. Okay, so you just how to do this? You just test by try and error. Okay, try n equal 1, 2, 3, 4, 5, 6, 7. Yeah, try and error. There's no inverse for factorial, right? So you just try number. You are allowed to bring calculator. So this means that n plus 1 have to be greater than 7 by try and error. So which means greater or equal to 7, which means n be greater or equal to 6. Okay, so meaning what? If you add up to 6, it is 3 decimal close to your original sum. Yeah, so if you do this finite sum up to the 6th term, you will get about 0.368. So the first 3 digit is the same as the original sum. But what happened at the back, don't know. how the 7 come? By try and error. Try and error. 1 over 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, and then yeah. Okay. Because there's no inverse for factorial, right? No inverse for factorial. We just try and error. Okay, let's introduce one more thing, then we can break. I mean, yeah, finish. Okay, finish. Where's the attendance? When? Today? What time? 10. 10? 10? Oh, is it? What's your test? What quiz? Oh, why only you? What? Wait. And this one cannot finish earlier is your fault. You can leave first if you want. I just finish one last sentence and then finish. Okay, I finish. Yeah, like so. One definition. Okay, so if an and the modulus of an, the series converges. Okay, then we say that an is absolutely convergent. If an converges but the absolute value diverges, then we say that an is conditionally convergent. Okay, so why we introduce this definition? This is specially tailored for the harmonic series. Okay, you need to remember this example to remember this definition. Okay, remember what? So alternating harmonic series and harmonic series. Harmonic series is the sum from 1 to infinity of 1 over n, and the alternating series is minus alternating sign on 1 over n. Okay, so harmonic series diverge, but the alternating harmonic series converge. So we will say that harmonic series is conditionally convergent. Very good. Okay. So another test is if you test that the absolute value of an, the series defined by absolute value of an converges, then an itself converge. Okay, so this is the absolute convergence test. If all the positive term add up converge, then the original, no matter how it plus and minus, it also converge. Make sense or not? Okay, the big thing. So the idea of this series is the big thing converge, the small thing also converge. Provided you can compare the two. Yeah.
Alternating there is conditional.
True. Okay. So it's the alternating harmonic series conditionally converge because because harmonic series already diverge, right? So how this alternating harmonic series converge? It is conditionally converge. Okay, because if you take the modulus, it diverge. Okay, thank you. Okay. Yeah, I mean, I want you to like keep in your mind first. Then next time will be easier. Tomorrow. Last week, less than. Yes. Yeah, we see. All right, so see you next time. Please pass me back the attendance. Eh, 哪一个讲？这个怎样来哈？这个没有怎样来，就直接跟你讲有这个东西吧。
讲出来。
哦，没有，喂，这个是跟这个一起介绍。 对，就这里就这里。
说
对，
那你父母去哪里睡？
啊？
那你父母去哪里睡？
没有地方去哦，
没地方去
没有
哦
地，方去哦。
带他去机场啊，
啊？
挑一顿这么多东西吃，
为什么？
不错吃哦。
那边哪里哦？
机场啊，
机场里面？
真的，
为什么？
我没有骗你，不错的，我蛮多东西吃。
真的咩？
哎呦，
可是那边 parking 不是要钱
有下班跟钱啊。
？OK，
这个哦，我不是要问为什么是4个小时位啊？为什么是0.000？
因为你0.005的话，你不是要进位吗？如果你看的区的新闻，
是啊，不是，我不是在问进位的问题，是为什么
可以0.000
啊
六嘛？
0.00006啊？
不能啊，你会拿到0.005，等一下，0.005的话你就要进位了。你0.0005啊，写成3个小数点，你这样写
0.000哦，
0.1
啊，
所以你小过0.0006的话，你就有可能性拿到0.0005，像你0.0005你就要进位了。
好难。
怎么难？
不是，现在就是讲哦，假设
我要
，OK，
你看，假设它这个号码是0.368嘛 ，OK，它要0.368嘛，但是你如果拿到0.3685的话，这样这个是不是等于0.369？
哦，
对吧？
那我可以写0.004。
我是在想0.01这个再是小过就可以了。
可是你那时候你就可能不是那个最大的 n 了咯，可能你就会拿那个最大的 n 去
啊，
原来
但是其实它
是不改
对，不准，其实真的是会不准，
是不是？
因为它不准哦，也不准，但是你只要 make sure 它第一个小过它了就可以了，第一个小过它。如果你0.0004啊，你可能找不到这个6，你可能找到5了，但是6其实我
OK，
不是0.00049哦，
呀这样的意思。
聪明。
等一下小过吗？不可以算5，不是49哦，
是啊，
这个变49给好。
四位数。
到底是在干什么？在懂这个简单话。
他要找那个
我上回没来。
OK 好，
卷子，秘书馆那个卷子
还没发的，
还没发。
哦，你没来，你有告诉我，
我没告诉。
所以你就没来吧？
没有。
没有原因啊。OK 好，
是我来。
可以3次，
哇，可以3次啊，
可以3次，
一次就 see you next time 了。
3个礼拜还是3堂？
2课吧？
3堂课，
没有变6堂课，因为你们是2次，因为你们2次，8先。
最后3个星期直接
哦，对哦，你们有6次可以不用来哦。
Yes。
可是哦，你一次没有来过，就完全听不懂我在讲么。
也是。然后
我来了以后，
这个的意思是说你要找这个 SN，
你觉得我是有那些？
它是3个 decimal accuracy， 就是你要 found 它的 sum correct to 3 decimal place， 其实它就是要找 SN such that 它是 correct， 它是3个 decimal place。
那个
出啦，你
就是找到它的 sum，然后让它
上次提前要测的事情，真的是
太酷了。
S3，然后它出来的数字是3 decimal places。
value 是知道
3个小数，3个小数。思路是就是你要 make sure 你的那个 difference
没有
小于0.00005，就是第4个小位数要少于，这样你就不会进位，这样你就在想
已经拿到3位数了是吧
3位数准，它第4位可以不准，它第4位可以不准，但是它第3位一定要准，前3位都要准。
所以我是用第4位来
第四位用第四位在它不会进位的情况下来 compare。
对啊，因为进位的话，你就把你的第三位
啊，所以才是0.005，因为0.0049是它的极限了。
对，
好像我讲的那个，
因为比如说
小过0.0005，
比如说
就是0.0009是它的极限。
比如说这个答案是0.0368的话，这样这个如果你要进位到三位数就是369，这样就错了，因为我要368，所以你要 make sure 这个东西是小于。
连接打4场都打，打1场都死了。
签到满了吗？
还有2次，下个题
学生签到满了吗？
还有2个，
有几个孔？
我觉得今天有15个孔吧。
啊，那你指哦，
不止
你
但是呢，
啊，
老板上满人，
我不要切啊！我不要切，我就不要切，我要切的时候我会切。
然后我
每次谁地抓2个？
对啊，有些是我抓了，
看那种老面孔，我没有来
就是
没懂面子，那名字记不得。有些我真的是连样子
都不懂。
啊，
当时帮你招到一个，
找到一个，
不要还有来。
看考试差的我就来教看，认识一下。
哦，
哎，不是那几个。
我想问一下哦，我不懂了。
不是，多少题还没有的，你应该要读完，不是你没有得上题啊，还有男人地位，
不恐怖，
你看呀，说不定没有得多。
这整个东西它是在来告诉我们，这个题 sometimes like 在这个 condition 下还 converge average， 它就是告诉我们有11个方法可以让它 converge average 嘛。
OK。
What's the purpose like 整个东西这样子
？What's the purpose is to compare。为了给你拿分数。
为了 purpose 是什么？你说应用在哪里啊？
就是来题，为什么有人要做11个 method 来找一个？
他还那个时候吃饱没事做，应该。
11个 method 啊。
它不会规律。
没有，因为有时候有些 method 比较好用，有些对于有些的 pattern 的function有些比较好。
所以我们就是为了找 pattern，这样我们有11个。
为了找 pattern， 就是为了因为有这种问题出现，然后可能这个方法我用不到，这样能不能再找另外一个方法来证明它？
整个东西都要 conversion average。
对，那个就是那个。
conversion average 其实最后
拎去什么东西？比如说我们 solve 那个题那个 probability 的东西啊。讲弄了。你要算一个东西的时候，但是那个东西有无限个情况，这样你能不能得到一些有用的？如果它infinite的话，你就不能够做。
OK 的，
恐怖才有。
后面有签名。
可能 diverse 的时候你会说可能呀不一定啦，depend on 你的 purpose， 但是呀
尾套。
OK，
这是尾套。
老师就是我想问一下这 S 是什么东西？
这个 S 啊，这个 S 就是那个 S infinity 哦，就是这一个
S
对，
那是它当时底线了还是？那这 SN 跟这 S 不是没区别吗
？SN 是 partial sum。
对 ，SN 是 partial sum， 对。
它的方式。
SN 是那个 S1、S2、S3、S4、S5、S6、S7。
就差不多。
这两个是一样的，难道不一样吗？
不一样。S1 是第一个啊，S2是 A1 加 A2 啊
，A 加2，
对啊。然后 SN 就是 A1 加 A2 加到 N 个，
因为它是没有正负的，是吧？我突然有那个，
它是大于
加在一起。
那它这样的区别是什么？
区别是你这个 n 可以为任何数，但是 S 你的 n 是 n 等于正无穷，但这个 n 这个意思其实就是 n 等于正无穷。
因为它 converge，它肯定是等于一个 finite sum，finite，因为它
S 它相当于趋近于正无穷，相当于对 n 是某具体的，就是只带一个得到一个
对
OK，
ST 上做 try and error 是什么？
就是你试一个号码咯，2 factorial、3 factorial、4 factorial。
OK，要先走。
你考试有没有改到过那种 sequence 啊？叫你找同伴怎么样？那个人 list 出来全部 list 100个，然后 complete 有
最原始的方法嘛，
是这样子啦。
这是最原始的方法。
有没有改过？对吧？
没有。
如果考试我这样子写，
我有改过一个，我考 discrete 考那个binomial expansion 然后我不是有教 binomial expansion， 你可以用 Pascal triangle。
OK， 然后 skip，
然后我的那个 power 开到32，
然后
真的，然后答案对嘛？
他算错了，这样说。
他答案对很屌，
他要整条，你知道吗？
他答案对就很屌，
答案是这样。
老师，如果他答案对哦，他的专注力真的是很屌，我跟你讲。
是，也是，我觉得也是。
如果对才是吓人，
给他1点分了。如果他答案真的对啊，我给他满分。给1点分啊，给1点分。
做的一定是啊，2个小时啊，有半个小时看题目，
了，
那1个小时半做2个，应该是其他的不。
对，他后面就空了，直接做了。
我来，一定是我呀。
他不是没有时间做，他都不好
没有，他一定是半个小时看的那些题目，他抓到啊，哎呀，只有这题我会做嘛，我就 S
也有可能。我也是真的是 respect 哈。
老师，因为在家以前是这样子啊，开4次方的时候我也是。
4次方 OK 吗？